All right, trig class. Finance class. I teach several classes, so sorry about that. All right, so we are going to be doing probability. Probability is super fun and super easy. So probability is the likelihood that an event will occur, like the probability you'll win the lottery, or the probability you'll get COVID, or the probability you'll get struck by lightning, right? Or the probability we get in a car accident. All these things are looked at to know our risk, right? And to determine if something is likely to happen. It's the same when they tell us there's a 60% chance of rain, or a 90% chance of rain, or a 20%. So that's all probability. So the probability A is any event. So that can be the probability of it raining, probability of lightning, anything like that. So when we set up probability, on the top will be the number of outcomes in whatever event we're talking about. So it could be, what's the probability of getting a King of Hearts? So we would put how many King of Hearts in the top. The bottom number should always represent the total possible outcomes in that event. Sorry, I almost spelled that wrong. Total possible outcomes in that particular event. Now, please note that probability, the answers are between the numbers 0 to 1, or if it was a percent, it'd be 0 to 100%. So we're either looking at decimals, fractions, or percents. Okay, so we're going to do several examples together, all different kinds of probability. So number 1, and you're going to be seeing the same kind in your homework. So the distribution of ages of drivers for this insurance company has a mean of 48 and a standard deviation of 10. They're looking at what is the probability a randomly selected person is less than 30 years old. So this is reviewing stuff from Unit 1, okay, that we did. When I see mean of 48, and I'll use a different color, I have a mean of 48 and a standard deviation of 10, and that's all they gave me, then I know they're wanting my z-score. Now, in your book, our z-scores are page 718 to 719. And I will go over that section in case you've forgotten. So to calculate my z-score, z equals the data number. And I entered this wrong at home. So less than 30, so I'm going to do 30 minus our mean divided by, so in your book, I believe it was like x minus the mean divided by standard deviation. So that's the formula I'm using, divided by 10. So 30 minus 48 equals negative 18 divided by 10. I get negative 1.8. So going to that page 718, I'm going to find negative 1.8. And there's the glare, I apologize. So here's negative 1.8. There's nothing after my decimal, so I'm going to record this bottom number, 0.0359. So from that table, negative 1.8 gave me 0.0359. So that means if I move that over, only 3.6% are less, or below it, are less than 30 years old. And we'll do more like that in a little bit, okay? They have us look at all the different ways we can calculate probability. So this next one, ratio. When I see ratio means fraction. So the ratio of male to female with a parking pass at this high school is 5 to 3. That can be read 5 to 3. If there are 64 students with parking passes, how many are female? So they're telling me that the male tickets plus the female tickets is a total of 64. So I'm going to solve this using substitution. So I'm going to rewrite the bottom of this one to be, well, I guess it doesn't matter which one you write. I'm going to rewrite this one to be that m equals 64 minus f. I subtracted f from both sides. And I'm now going to substitute this into the other equation to solve. So I'm going to write 64 plus f over f equals 5 over 3. And then the easiest way to solve ratios is to cross multiply. So 5f, right, f times 5 equals 3 times 64 plus f. We're going to distribute, so 5f equals 3 times 64, which is 192, plus 3f, so 2f equals 192. Divide by 2. Did I do something wrong here? Oh, this should be minus. I'm like, I did something wrong here. So this is 8. And 192 divided by 8, there are 24 females. Next, number 3. So using a table. These are can be kind of confusing, so I'm going to try to walk you through it. So here is a table. Notice I have freshman, sophomore, and junior. Gives me my totals at the bottom if you look at your column. So the total freshman, total sophomore, total junior, and then total totals. And then on the left, it's those who bring their school to lunch, those who buy and those who bring. So here we go. Find the probability that a randomly selected person from this group brings their own lunch. So brings their own lunch, the total people that bring their own lunch is 145 over how many total people? 265. And it says to express our answers in fraction form. Now, if they have you leave it, fine, but if they ask you to reduce it, I'm going to divide both of these by 5. And I get 29 over 53. Next one. What is the probability that a randomly selected person is a freshman? So there are 82 freshmen who brings their own lunch. Okay, wait. A freshman who brings their own lunch? Freshmen bring their own lunch. Out of the total people, 265. And I'm going to leave that because it cannot be reduced. Next one, find the probability that a person from this group is a junior given that they buy the lunch at school. Now that changes everything and can be written like this. Probability that it's a junior given that they buy, and they use the letter B up here for buy, they buy their lunch at school. So the first number should represent juniors, so the J. So juniors. However, I have to look at they're a junior, but they buy their own lunch. So 49 juniors buy their own lunch. The bottom number should be the number of people that buy their own lunch. So the second number should be your bottom number. So buy lunch is 120. The top is from both categories. So the top should be junior and buys lunch. The bottom is the total people that buy lunch. So let's try that again. Find the probability that a randomly selected person buys lunch at school. So probability they buy lunch given that they're a junior. So this time, find the row or column that it has to do with B. So here's B, and I see that they are 49. The difference is the total number of juniors. The second number should be what's on the bottom. There are 93 juniors. It's kind of tricky. All right, so last two. Find the probability of F. So the probability of F would mean the probability that I selected a person who is a freshman. So there are 82 freshmen, and there are a total of 265 people. To write that in a decimal, I'm simply going to take my calculator and do 82 divided by 265, and I get 0.309. It did say 2 decimal places, so 0.31. Next, find the probability of B. If you look above, that's people who buy lunch. So if I go up above, people that buy lunch is 120 out of 265. To make it into a decimal, you enter it in your calculator. 120 divided by 265, and I get 0.45. Moving on, there's still a couple more, and I'm actually going to skip. Well, and I'll do one of them. What's the probability of J? So how many juniors are there? There are 93 juniors out of 265. So 93 divided by 265 is 0.35. This next one, juniors that L. So juniors of L is 44. Given that they are bringing their own lunch is out of 93. So remember, when it's written like that, that second number is your total. 44 divided by 93 is 0.47. So this one is greater. We're not going to do H. All right, moving on. Number 4 says we have 42 seniors. Twins, Robert and Leslie, each own their own cars. What's the probability that neither of their cars will be selected for the yearbook page? So if there's 42 and neither of their cars are selected, well, Robert and Leslie each have their own car, so 40. So there are 40 people other than Robert and Leslie out of 42. And so the probability is 40 out of 42, or you could reduce that to be 20 over 21, or 0.95. However, the book requests your answer as a decimal or fraction. All right, Venn diagram. Okay, so these can be seen as kind of complicated, but here we go. C represents air conditioning. So all 4 of these numbers are people that bought air conditioning. But these are people who didn't. So if it's in this circle, it has A and C in common. In this middle, they have all 3, right? So you look at those overlapping. This number down here means that none of those cars fit into these categories. So A is AC, air conditioning. C represents a CD player. And T is an auto transmission. I don't know if you care, but that's what they mean for. How many people bought cars with air conditioning? Okay, well, it's these 17 plus 7 plus 11 plus 5. It's all 4 involving C. So it'd be any number in that category, and if you add those up, I got 40. How many people bought cars with automatic transmission and a CD player? So how many have all 3? It would be that middle number in the center. Oh, whoops, I read that wrong. How many people got automatic transition, T, and a CD player? So it would be this one here, 5. How many people purchased car with all 3? That's the very center. How many people purchase cars with exactly one of these options? Well, that would be the numbers that have no overlapping circles. So 21 plus 12 plus 17, and that gave me 50. How many people purchase cars? You have to add all numbers. So if you add every single number in here, I got 100. A buyer from this group is selected at random to receive a free satellite radio. What's the probability that they purchased a CD player? Well, I would have to total up all the ones that bought a CD player. So 17. Oh, that means that I got this top number wrong because this is air conditioning. My apologies. AC is 21 plus 9 plus 7 plus 11. So this is 30 plus 18, 48. I forgot that A stands for AC. C stands for CD player. So there are 40 that bought a CD player, but there are a total of 100 people that bought a car. So this would be 2 out of 5, 2/5. Next one person from this group is selected. What's the probability that they purchased a transmission? So I have that 9 plus 11 plus 5 plus 12. 9 plus 11 plus 5 plus 12 gives me 37 out of 100. Bottom, we're going to skip H. All right, so number 6. So these all have to do with z-scores. So what's the probability? So here's my mean. Here's your standard deviation. So if I spent $54 minus your average divided by my standard deviation. So 54 minus 46, I got divided by 8, I got exactly 1. So using your book, go to page 718, and I'm looking for 1. And here's 1.0.8413. 0.8413. And so remember, I'm on page 718 and 719. So if that is how many people, I have to subtract. So 84% spent less. So I have to do 1 minus 0.84 minus to find out who spent more. And that gives me 0.1587. So I'm going to say 16%. What is the probability that the person spends less than $54? Well, I already found out how many more. Less than would be the 84% from up above. What is the probability that or you could say 84 out of 100. It says, nearest hundredth. So this would be 0.16. This would be 0.84. So sorry, they wanted it as a decimal, not a percent. So 0.8413 would just be rounded to 0.84. What's the probability that they spend between 22 and 70? So I have to find the z-score of both. So let's start with 22. 22 minus the mean divided by 8, I got negative 3.0. The z-score for 70 would be 70 minus 46 divided by 8, and that gave me positive 3.0. So using that table on page 718 and 719, I'm going to look at both. So here's negative 3.0 at 0.0013. So 0.0013. Now I'm going to look at positive 3. So that's way down here. 0.9987. So 0.9987. So if I want to look for between, I have to subtract. So 0.9987 minus 0.0013 means that would give me 0.9974. So, and it said to round to the nearest hundredth, so 0.99. What is the probability someone spends less than 50? So I'm going to do that here. So z-score 50 minus our mean divided by 8 gave me 0.5 or 1/2. So looking up the table, 0.5 is here at 0.6915. So that would be 0.69. So there are the answers there. All right, number 7, my favorite. Here is a 6-sided number cube, and on each side are the following numbers. If the cube is rolled, what is the probability of getting an even number? So what's the probability of even? So let's count how many even there are. 1, 2, 3, 4. Out of 1, 2, 3, 4, 5, 6. So that would be 2/3. Part B, what is the probability? It is prime. Okay, prime numbers are numbers divisible by 1 and itself. So that would be 2 and 7. So 1, 2, there are 2 of them. Out of 6, that would give me 1/3. What is the probability of a number not divisible by 3? So which of these numbers cannot be divided by 3? Well, 2 can't, 4 can't, and it means evenly. 7 cannot, and 8. So the probability that it's not divisible by 3 equals 4/6, or 2/3. Now, when I roll a dice, one roll does not affect the other. So if he rolls a 3, what's the probability he rolls another 3? It never changes. So there is no 3 on this dice. Is that a typo? Because there's no 3. So I'm assuming it means a regular die, which means there's only 1 3. That was weird. There must be a typo. Number 8, I don't think you're going to need to build an actual Venn diagram, but if you are, this says that there are 210 seniors. It says that L goes out for lunch and has a first period class is F. So I've got L, this doesn't need to be, let me draw this a little bit better. And I know there's usually a box. So this is a really bad picture, but L and F. It says that 80 do not go out for lunch, and 80 do not have a first period class. So that would be out here. It's not in either. It says that from a survey they found that 90 students who go out for a lunch with their cars, only 60 do not have a first period. So 60 go out for lunch, but do not have a first period. Now, of 210 seniors, minus 90 minus 80 means that 40 had a first period. And that should cover the types of problems you're going to see.